Okay, so here is video number 1 for the week. What we're going to be doing is we're going to be classifying circuits. So like I said before, it's not a great idea to get into a habit of calling things series circuits and parallel circuits, because when we start to get to more complex circuits like you see here on the right, then those phrases tend to fail us. So I really wanted to get you in the habit of saying things are wired in series or wired in parallel, because that's really how real circuits are. We're going to start with the two on the left here that we are most familiar with. Now, on the top left here, so instead of calling this a series circuit, what we're going to want to say is that bulbs 1, 2, and 3, or in this case resistors 1, 2, and 3, are all wired in series with each other. You could technically say that they're wired in series with the battery here, but saying that they're wired in series with each other is just fine, because really we're usually trying to talk about how resistors or light bulbs or whatever are wired into a circuit in relation to each other. Sometimes we're talking about the voltage source, but more often than not we're talking about how the resistors are wired in relation to each other or other resistors. So number 1 here, top left, these 3 resistors are wired in series with each other. And then we go down here, and this is like the exact opposite. Again, we don't want to necessarily call this a parallel circuit. What we want to say is that all 3 resistors are wired in parallel with each other. You could say they're wired in parallel to the battery here, but either of those works out just fine. But really, we just want to talk about how they're wired in parallel with each other, not really a parallel circuit. Now, what we've got here on the on the right, are the other 2 ways we could wire 3 bulbs or 3 resistors into a circuit. When you've got 3 resistors and a voltage source, these are really the only 4 ways that you can do it. There's a lot of different ways you could hook up the wires to make this happen, right? Like with this circuit down here, we could have wired each one instead of kind of like a ladder. We could have just taken a wire and gone straight to each side of the battery, and we would have gotten the same result, because we know that in parallel just means to be in their own separate paths. So as long as they've got their own separate paths, you can hook the wires up any way you'd like, but the schematic is going to look the same. This is kind of the neatest way to draw it. Like we said, we want to go very boxy, so I'm just trying to wire them up the way you would probably see them drawn in a schematic. So in that case, we're going to actually stop showing the current, and we will go to these schematics the way they look like this. All right, so we got schematic 1, schematic 2, and over here we've got schematic number 3. Now, here's where it starts to get a little bit tricky, and we need to kind of start labeling the resistors, because before it didn't really matter because all the resistors were wired the same way, either all in series or all in parallel with each other. But now we're going to be a little more careful. So I'm going to call the one on the top here resistor A, and then these 2 down here will be resistors B and C. And the way we have to talk about this is we got to kind of do it in 2 parts, right? Because we've got some complex stuff going on here. So what I would say first is that resistors B and C are wired in series with each other. So that tells us right now that they are in the same branch or the same path of current, which we can see right here, right? They're in the same little leg of the ladder. So B and C are wired in series with each other. Then we got to talk about how those 2 are wired in relation to this 3rd resistor here, resistor A. And the way you'd want to do that is by saying the branch containing B and C is wired in parallel to resistor A. Or, the BC branch is wired in parallel to resistor A. So that's just telling you that you've got 2 separate paths. And in one path, you've got resistors B and C, and in the other path, you've got resistor A. So 2 sentences for this one. Resistors B and C are wired in series with each other, but the BC branch is wired in parallel with resistor A. Now down here, there's a lot of different ways you might see this one drawn. You might see it drawn like this, you might see it drawn like this, but they end up giving us the same schematic, right? So if we go up here, we can see if we turn off the current here. Let's make that a little more straighter. Yep, there we go, nice. Okay, I'm not going to play around with that anymore. Sorry. So we've got 2 separate branches you can kind of see here, where we've got 1 resistor in one, 2 resistors in another. But when we go to this one, really we've got these kind of 2 in parallel with each other, but they're in the same kind of main branch as this one. And that looks the same as this one right here. right? It's kind of the same result, just drawn a little bit differently with the wires connecting in. And in the real world, that might make a little bit of a difference, where a little extra wire might mess with your measurements a little bit more because of wire resistivity. But for the sake of drawing schematics, I don't know, I tend to prefer this one because I think it's going to be a little more clear as to how the way things are wired. But either one of these two is going to give you the same electrical result. So we're going to start with this one here. So like in this one up here, we had two resistors kind of wired where we could kind of talk about them isolated on their own, and then talk about how they're wired in relation to this other one. We're going to do the same thing down here. As we can see that this little section here, if we ignore everything else, just this section here is two of these resistors wired in parallel, right? It kind of looks like this. If we could just cover up this third one here and pretend it didn't exist, it would look like that. So the way we're going to classify this is, again, we're going to say this is resistor A, resistor B, and resistor C. We're going to say that resistors B and C are wired in parallel with each other. So just like up here, resistors A and B were wired in series with each other. Now we're going to say resistors B and C are wired in parallel with each other. And up here, like we said, this branch was wired in parallel with this. So we talked about how these were combined, wired in relation to this. We're going to do the same thing here. So we've already said B and C are wired in parallel with each other, but that parallel combination is then wired in series with resistor A. So we've got this parallel combination that's sitting in the middle of this one main branch. Right? The current, as we can see if we watch it, the current comes through, flows down, flows around, but then when it gets here, it splits off into these two branches, right? See, this electron's going to go down, and then this electron's going to go up. And if we crank the voltage up a little bit more, we can see that go a little bit faster. Right, so the voltage splits up, one up, one down, one up, one down, one up, one down, one up, one down. But we've still got this same main branch, right? Because then they come back together here, right? They connect and then form that main flow of current again. So this thing, this complex combination, we've wired it in series with this branch here, with this resistor. Right? We've still got one main branch, kind of like here, but we've then stacked these two resistors on top of each other to make a parallel combination in the middle. So the two sentences we would want to say for this is resistors B and C are wired in parallel with each other, but that parallel combination of B and C are then wired in series with A. Right? So these two are in separate paths from each other, but they're in the same main path as A. Right? All the current that flows through A flows through either B or C. Now, you wouldn't necessarily want to say A is in series with B and C, because that's kind of what's going on over here, right? Resistor A is in series with B. It's also in series with C, right? In series means in the same branch. So you got that's, then you run into like if A equals B and A equals C, then B equals C sort of situation, right? If A is in series with B, but A is also in series with C, that kind of means that you're in series with both of them. Then B is in series with C, which works over here, but not so much over here. Right? If we say A is in series with B and C, then it's a little confusing because these two aren't in series with each other. So the kind of careful way you want to say it is B and C are wired in parallel, and that parallel combination is wired in series with A. So you can think about it as B and C are in separate paths from each other, but their parallel combination here shares a single path with resistor A. Right? So this one single path then splits off into two, then comes back together to go back into the battery. That's probably the most complex one. But then of course we're going to start throwing all sorts of combinations of these two together, and we'll see how that goes. But that's how we're going to want to classify circuits, right? We're going to want to say series circuits, parallel circuits, like that. Like this is a circuit. This is a circuit. This is a circuit. This is a circuit. And we've got different ways that things are wired into those circuits. Here we've got all three bulbs wired in series because all three bulbs are in the same path. Here we've got all three bulbs in parallel, or resistors, bulbs, same thing at this point. All three resistors are wired in parallel because they're all in their separate paths. We've got these two, B and C, wired in series with each other, right? They're in the same path. The current that goes through B also goes through C. But that series combination there is in parallel with resistor A. Right? So this whole branch is in parallel with this branch here because they're connected up to the same voltage source. And then down here, we kind of say the opposite of that. These two, B and C, are wired in parallel with each other, but that parallel combination is then wired in series with resistor A. These two are in separate paths from each other, but they both share a main path with this third resistor here. And hopefully that helps to clarify things up a little bit, and we'll be using that as we move on to now starting to analyze complex circuits, because the rules we came up with for how voltage and current work in series and parallel are going to be very dependent on how we classify those circuits. And if we classify them this way, then using those rules to identify missing measurements is going to be very, very easy. So hopefully that was helpful, and I will see you in the next video.